All right, let's go ahead and talk about the types of chemical reactions. So, by using patterns, we can identify different types of chemical reactions, which will help us to predict the products. There are 5 types of chemical reactions we are going to talk about. The first type of chemical reaction is synthesis reaction. And a synthesis reaction is a reaction in which multiple substances combine to form a new compound. And the kind of structure of a synthesis reaction is A plus B yields AB. Now, the second type of chemical reaction is decomposition reaction. And a decomposition reaction is a reaction in which a single compound breaks down to form 2 or more simpler substances. And that kind of structure for this reaction is AB yields A plus B. Now, this is the opposite of synthesis reaction. Okay, so we just talked about synthesis and decomposition reactions. So let's actually go see those reactions in real life. Right here, I have an apparatus called the electrolysis machine. And what is inside here is water with a little bit of acid, because an acid's going to be a catalyst. Catalysts are substances in a reaction that helps speeds it up but doesn't change what is going on in the reaction. So what I'm going to do is I have like a battery system with little clips. It kind of looks like a jumper cable, what you would jump a car with for the battery. And we're just going to go ahead and connect these, no particular order, onto these metal sticks here. And then we're going to go ahead and turn on the machine. All right, and I'm just going to go ahead and we're going to put some electricity through it. And as you can see right now, is if you look at these metals, it's sending electricity through the liquid and you start seeing it bubbles. So while we let this wait to do its thing, let's go ahead and look at the board. And what we're looking at right now is we're currently looking at a decomposition reaction, and we're actually tearing apart water. So originally we have H2O, and what's going on in this reaction is we are actually going to break this apart and produce hydrogen gas and oxygen gas. And when you look at this reaction as balanced, we have a 2 in front of the H2O and 2 in front of the H2. Okay, so pretty much we know this is a decomposition because, again, there's only going to be one compound in the reactants, and we see one compound in the reactants. All right, so I kind of let the electrolysis machine do its thing for a while. So looking back at the electrolysis machines, this is what it looks like. We have a lot of gas over here, and then we have just a little bit of gas collections over here. So looking at that difference. Now, what I'm going to do now is I'm going to do a synthesis reaction. And what I'm going to do is what you're going to see is I'm going to take that hydrogen gas that we just collected here, and I'm going to react it with the air, okay? And we know our air is pretty much oxygen. And when I react these two together, I am going to reproduce water, and you will see that happen. And I bet you're like, Miss Winkle, how can you just magically make water? We're going to see in a minute. Now, remember when I talked about the catalyst to make this electrolysis machine work, is our catalyst was a little bit of acid. Well, we're going to have also another catalyst, and that is going to be fire. That's going to be flame. That's going to be heat, and to make this reaction go faster. And again, looking at the balancing of this reaction, we're going to have 2H2 and 2H2O. Now, looking at this reaction, we have 2 H2 gases per 1 O2. So that means we're going to be producing a lot more H2 than we are with oxygen. So looking at our electrolysis machine, so let me go ahead and turn this off for us. We have this amount of gas we collected, which is a lot, significantly a lot, versus this. Because we are producing a lot more H2 gas, we know this one's going to be H2 gas, and this one's going to be O2 gas. So what I'm going to do is I'm going to take a test tube, I'm going to put it over here, I'm going to get my match ready, And you're gonna watch me do it and you're gonna hear a big pop. Okay. So I'm gonna light my match. I'm gonna collect my O2. And then collecting that, if you look, you're gonna start seeing condensation against the test tube, and you see liquid against the test tube, and that is H2O that we just produced. The next type is combustion reaction, and a combustion reaction is an oxidation reaction of an organic compound in which heat is released. And with the combustion reaction, CO2 and H2O are always the products. And this is kind of the structure for that. We have two different organic compounds we can have. They can have X, Y, R, can be any number for the subscripts, plus O2 yields CO2 plus H2O. It always will end in plus O2 for your reactants, and it'll always be CO2 and H2O in the products. Alrighty, so now what we just talked about, we talked about composition reactions, and those are when an organic molecule reacts with the air, and it's always going to produce CO2 and H2O. Usually combustion reactions are usually involving fire or heat of some sort. So looking at the electrolysis machine again, we're going to use that one more time and see what combustion reactions look like. So the combustion reaction, what I'm going to do is I'm actually going to take a piece of wood, and wood is CH4, organic molecule. And what I'm going to do is I'm going to react it with the air again. And again, I'm going to use heat and fire as a catalyst. And what is going to be produced is we're going to produce CO2 gas, which is going to be the smoke, the smoke that you're going to see in the test tube, as well as H2O, which is going to be your water droplets and your condensation against the test tube. So let's go ahead and take a look at that. Okay. So we just did the H2O reaction, so we have no more H2 gas, but we have oxygen gas. So I'm going to go ahead and put a new dry test tube there, and I have a wood splint here. So what I'm going to do is I'm going to light this splint on fire. I'm going to collect our oxygen, blow this out, and it's going to relight. See the relight because it's reacting with that oxygen inside. And then if you look closely, you see your smoke, which is CO2, and you're going to start seeing water droplets and condensation against the test tube, and that is your H2O that we just produced. And there you go. The next one is a single displacement reaction. It is a reaction in which one element takes the place of another element in the compound. And as we can see, we have A plus BX yields B plus AX, meaning the A took the place of the B, and now B is by itself, and A is with X. Okay, so now we're going to do two examples of single displacement reactions, and they're my ultimate favorite reactions to do, because I'm going to be producing something pretty cool. So I have two graduated cylinders. I would do test tubes, but these are big enough and cool enough where you can actually see what's going on. Now I have aluminum rod. This is pretty much foil, but it's compacted and pretty thick into wires. And I'm going to go ahead and cut two pieces off. And I'm going to go ahead and stick them in here. Okay. Now, one of these, I'm going to go ahead and put copper sulfate. Now, copper sulfate, you see, it's pretty blue, kind of a really pretty color blue liquid. We're going to go ahead and pour that into one. Okay, and for this reaction to actually happen, again, we're talking about catalysts, something to speed up the reaction. We're actually going to take hydrochloric acid, concentrated. This is the most concentrated hydrochloric acid you will find, so it's pretty dangerous. We're going to put a little bit into that test tube. It has a very potent smell. There we go. And we're going to go ahead and let that react. And then I'm going to take the HCl, I'm going to put it in here, and just have one with just HCl in it. gonna let that sit. Seal this back up. Alrighty, we're gonna let this go. As you can start seeing, we see some bubbling going on, something going on. So we're gonna revisit back and we're gonna go back to the whiteboard and we're gonna talk about these two reactions happening, okay? The first one with our copper sulfate, we had aluminum wire and we added copper sulfate, which is CuSO4. Now we were just talking about that single displacement, something is switching. Okay, how I like to talk about this, and we'll go more in depth with this in a couple days, is someone is stealing someone's girlfriend. Easiest way to explain it. So what is going on is aluminum is going to steal CO4 from copper. So CO4 is going to go with aluminum. So what's going to happen is we are going to produce aluminum sulfate, and then copper is going to be single, okay? So what's gonna happen is actually the aluminum is gonna become copper, and then the blue liquid is gonna become clear, and we'll see that towards the end when the reaction's done. Now this reaction here with just the HCl, what we see is aluminum is reacting with HCl, hydrochloric acid. And again, someone is stealing someone's girlfriend. Aluminum is stealing chlorine from hydrogen, so chlorine is going to go with aluminum. So what you're going to produce is we're going to get aluminum chloride, and we're going to start producing a hydrogen gas. Now this one, our first one, our copper was our solid, so we're going to still see some solid. But this time we have a solution and we have a gas. There's not going to be any more solids, so that aluminum is going to go away at the very end. So we're not going to have any more aluminums at all. And these are your reactions. So we're going to check back in a couple minutes and we'll resume back the video when this reaction is finally over. Sometime, it's been about 10-15 minutes letting these reactions go. So let's go ahead and check back on our single displacement reaction. So let's go ahead and look that out. So this one, if you remember, was very, very blue. Well, look, now it's very clear. And we got copper, our copper solid right here. Very cool, right? And this one, as you can see, it's very, very bubbly. But as you can see, our aluminum is getting very, very, very thin. And if you looked at how it originally looked, it's very thick because it's eating it through. And here's that aluminum shell that is coming on up and it's dissolving a little bit. And this solution is becoming very cloudy white. And if we let this sit any longer, that aluminum is going to be completely go away. And this aluminum is going to be completely copper. And that's it. Just in the process of cleaning it, and look, the aluminum is all gone. And then looking back on the copper, we just produced a lot more copper on here.
And the fifth type of reaction is double displacement reaction. And a double displacement reaction is a reaction in which two compounds appear to exchange ions to form two new compounds. And the structure of that double displacement reaction is AX plus BY yields BX plus AY, where the A and B switches places. So the A is now going to be with the Y and the B is going to be with the X.
All right, the last type of reaction we just talked about is double displacement. So let's go ahead and do some real life examples of those. So I have copper sulfate and I have barium chloride, okay? We have a blue solution and we have a clear solution. So when we go ahead and put those together, copper sulfate, very blue. Go ahead and seal that up. And then we got barium chloride. As you can see, it's very cloudy. What it means by cloudiness is a solid has formed. And we see it got very lighter blue. So let's go ahead and let that sit, and you're going to see the solution settle on top and that solid settle on the bottom. So let's go ahead and look at that reaction. So what we did is we took copper sulfate and we reacted that with our barium chloride. Now again, remember, it's a switch between ions. It's usually a switch between anions. Remember from Chem A, anions are negatively charged ions. So what is happening is our sulfate, which is a negatively charged ion, and our chlorine, which is our negatively charged ion, are switching. And what we're producing is we're producing copper chloride and barium sulfate. And that barium sulfate is going to be our solid. This S in the parentheses represents solid, and that's what that light blue solid forms. And again, you can start seeing it settling down right now. Okay, so let's do another one of these double displacement reactions. This time I have FeNO3. We see it's a very clear orangey solution with sodium hydroxide, which is a very clear liquid. So let's go ahead and pour. As you can see, again, it's a very orangey clear liquid. I'll seal that back up. Then let's go ahead and pour our sodium hydroxide. And as you can see, again, we're getting that cloudiness again. So this cloudiness is representing a solid, and then we have our clear solution down here, and it's producing a solution. So we're gonna let that sit for a minute, and you're gonna see very vividly that difference between a solution and a solid. So let that sit. And let's go ahead and look at what that reaction actually looks like. So again, what we did is we took iron 3 nitrate and we reacted that with our sodium hydroxide. Again, in these reactions, there is a switch between our anions. Anions are the negatively charged ions. So we're taking our NO3, which is a negatively charged ion, and our hydroxide, which is a negatively charged ion, and they're switching, and we are producing iron 3 hydroxide, actually iron hydroxide, not iron 3 hydroxide, and sodium nitrate, okay? And this iron 3 hydroxide is going to be the solid, that solid substance in the reaction. That's what we're going to start seeing. Again, so you can start seeing splitting up on the very top. It's very cloudy. All right, our last reaction we're going to look at is between potassium chromate and lead 2 nitrate. So potassium chromate is a very yellow solution. As you can see there, it's a very clear yellow solution. And we're going to go ahead and react that with lead nitrate, which is a very clear solution. And we got a very bright yellow solid solution that's being produced. So we're going to let that sit and wait for that to divide. And looking at that reaction, what we did is we took our potassium chromate and we reacted that with our lead, I believe it was lead nitrate. And again, double displacement reaction is a switch between ions, specifically our anions. So our anions in this case is our chromate and our nitrate, and they're switching, and what we're producing is potassium nitrate and our lead 2 chromate. And our lead 2 chromate is going to be our solid in this case. And let's go take a look at that. Our first reaction, you can see the solid at the very bottom, and our solution is on the top. Again, we're still trying to separate that solid. Looking at this one, a lot of it kind of ate away a little bit, but as you saw originally, it was a solid formed. And then this one, as you can see, there's a solid at the bottom, and that yellow solution's on the very top. And it kind of looks very foamy a little bit too. And those are your double displacement reactions.
So with this idea, you are going to need to know, if I give you chemical reactions, you're going to be able to and need to identify what type it is. So here are some tips and tricks to do that. First, for a synthesis reaction, we're only going to have one compound in the product side only one. For a decomposition reaction, one compound will be in the reactant side only. For combustion reaction, only CO2 and H2O will be in the product side. For a single displacement reaction, it's going to be an element plus a compound yields an element plus a compound. And what I mean by element, it's going to be an element completely by itself with no other elements in that quote-unquote compound. And double displacement reaction will be a compound plus a compound yield a compound plus a compound. Now remember, a compound is with multiple elements being put together. So with that idea, let's go ahead and do some practice problems. So we're going to identify the type of reaction for each chemical reaction. So problem number 1, we have N2 plus 3H2 yield 2NH3. And remember these tips and tricks. What you should do is you should go first eliminate synthesis, then move on down. Process of elimination. So our first reaction is synthesis is one compound in products. Remember, products is to the right of our yield sign. And looking here, we have no plus sign, so we have one compound in our products. Therefore, problem number 1 is synthesis. Problem number 2, we have CH4 plus 2O2 yields CO2 plus 2H2O. Again, doing that process of elimination. Synthesis, one compound in products. Well, in problem number 2, we have 2 compounds, so it cannot be synthesis. So moving on to the next one, we have decomposition, one compound in reactants. Well, for this one, we have multiple compounds in our reactants, so it cannot be decomposition. Combustion, only CO2 and H2O in products. Well, looking at our products, we only have CO2 and H2O. So therefore, this reaction is combustion. Problem number 3, we have PbCO3 yields PbO plus CO2. Again, doing that process of elimination. Synthesis, one compound in products. In this problem, we actually have 2, so it can't be synthesis. Decomposition, one compound in reactants. Looking at a reactant side, we have no plus sign, so it's one compound. One compound in reactant, meaning it's a decomposition reaction. Problem number 4, we have 2Cr plus 3FeNO32 yields 3Fe plus 2CrNO3. Again, we got to do that process of elimination. Synthesis, one compound in products. We have more than one compound in our products, so it cannot be synthesis. Decomposition, one compound in reactants. Well, we have way more things in our reactants, so it cannot be decomposition. Combustion, only CO2 and H2O in our products. We do not have CO2 or H2O in our products, so it cannot be combustion. Single displacement, element plus compound yields element plus compound. Well, in this case, we got an element by itself, so that's classified as an element, plus we have many elements together, so it's a compound, yields Fe's by itself, so it's an element, plus multiple elements together, that's a compound. So we have an element plus a compound, yields an element plus a compound. That is what single displacement is, so our answer is single displacement. Problem number 5, CdNO32 plus Na2S yields CdS plus 2NaNO3. Again, doing our process of elimination. Synthesis, one compound in products. Well, we got multiple compounds, so it can't be synthesis. Decomposition, one compound in our reactants. Again, we got multiple compounds in our reactants. It cannot be decomposition. Combustion, only CO2 and H2O in our products. Well, we don't have CO2 or H2O at all, so it can't be combustion. Single displacement, element plus compound yields element plus compound. Well, looking at our reaction, we don't have elements by itself. We actually have multiple compounds, which, last resort, double displacement, which is a compound plus a compound yields a compound plus a compound. We have a compound plus a compound yields a compound plus a compound. So it's going to be double displacement. Okay, so go ahead and do problem number 6 on your own. So go ahead and pause the video, and when you have your answer, press play. And the answer is synthesis. Okay, so go ahead and do problem number 7 on your own. Again, pause the video, and when you have your answer, press play. And your answer is decomposition. Go ahead and do problem number 8. Again, pause the video and press play when you have your answer. And your answer is synthesis. And go ahead and try the last problem for today. And pause the video, and when you have your answer, press play. And your answer is double displacement. And that's it.